Okay, Assalamualaikum warahmatullahi wabarakatuh. Today on programming technique this week. Okay, so this is our third class basically for the programming techniques. Last week we take a look on algorithm and how to construct them, and today we are going to talk about basically the introduction to programming. Okay, so means how exactly you do the coding. So before this, I gave you some samples of the codes, which mostly related to Hello World, right? So you guys got some of the idea of how the codes work, but what exactly the symbols, what exactly the words used in the codes. So today I will take a look in it, and there will be an exercise later on for your lab as well. Okay, which is not that difficult yet. It's just I'll give you some codes, and you will try to run it and try to modify it a little bit. Okay, so that you are going to feel confidence to do the coding from by doing some modification first. I myself, before I start doing coding, I imitate a lot of other people codes. Okay, once I am used to the codes, the algorithm from other people's, I can write my own from the beginning myself. So this is one of the most efficient way to learn programming. Okay, needless to say that copy paste help you learn programming a lot. Okay, I myself also learn a lot from copy pasting, and I encourage those in the computer science department also learn through copy pasting. And when you copy paste, you will realize some of the codes function, and then you will modify those code according to your preference lah. Okay, so now, before we begin all those coding things, okay, for today class, okay, I will demonstrate an ability to use a programming tool to execute a sample program, which we had done so far in the beginning. And then I will tell you how to apply basic elements, okay, so preprocessor directives, header files, identifier, reserved word for a simple program. So this is what we are going to do today. So let's start with the first one. First content for today is history of programming. Okay. So basically, computer programs, okay, also known as software, okay, they are instructions to the computer. So programming begin is actually before 1940s. Okay, they use memory addresses and machine code directly. So basically, programming. When you see programming, how do you do programming? Programming. Okay. Yesterday, I had a discussion with your seniors lah, from Faculty of Computing, some masters lah. So they say that how can you be good at programming? Okay, how can you be good at programming? So programming doesn't need you to like it. Okay, you don't need to like programming to do programming. Okay, you need to like what you can do with programming, then you can like programming. So how can I say that? Okay, like for example, I myself, I like to do some kind of robotics things. Okay, so I like to move using a robot, move the robot left, right, and if it got some obstacle, react to it. Okay, so this is motivate me. This is what motivate me to learn the programming languages so that I can do those kind of things. So when you want to learn programming, basically you need to know what you want to do with it. Okay, it's not like when you're doing programming, it's like you are given white paper and do some coding, anything. Okay, no, you need to know what you want to do. If you don't know what you want to do, later on you will have trouble in troubleshooting the algorithm. So this is what really happened in computer science department. Basically, when we ask students to do their final year project, everything, they don't have a clear view of what they want to do. And then at the end, their program become rubbish. So in case you, as a science students, usually when you are going to do programming, your programming might be related to analysis. Okay, analysis. So when we talk about analysis, biological analysis, chemical analysis, most of them involving statistics. So when you involve statistics, what do you want to know from those statistics is the most important thing when you conduct a programming. Okay, so I myself also involved in statistics involving in related to signal processing. So from the signal, what we want to understand. So this is also important in terms of observation of chemicals reaction, chemical compound, and also some biological pattern. Okay, so all of this involving a lot of analysis that can be solved using the programming languages itself. Okay, so let's just say, okay, I give you one example. In 1940s, what do you think they use programming for? Can anybody answer me? 1940s. Don't know. Nobody can answer. Nabila, can you answer me? What did they do with programming in 1940s? No one, nobody.
World War One, two.
World War One. No, no, no. World War One is in 1908. It's not World War One. It's World War Two. So what do you think they use programming for World War Two? Fitri, yeah. Fitri.
To
What do you think?
uh, send apa? Send code to
What kind of code? What kind of code? I don't know what kind of code.
Morse code.
Morse code. No, no, no. It's not Morse code. Morse code, they use Telegram. Okay. Telegram and programming is different. Telegram, it's also a form of programming juga. Tapi but it's a different tool lah. So basically, in 1940s, what they do for programming is they encode and decode messages. So this is what they did. Okay, encode and decode messages. What they mean by encode and decode. Okay, during my when I was little lah. Okay, umur belasan tahun, no, even 10 years old, 11 years old lah. I have a few aunts, okay, makcik-makcik, okay, few aunts, okay, who are in middle school. Okay, diorang ni, okay, those my aunts here, two young aunts, okay, they like to talk in codes. Okay, like for example, they don't want to let other people know what they are saying. They invent a new language called Bahasa F. Okay, I don't know whatever what things are that lah. What the hell are they talking with that? Okay, and then the Bahasa M, Bahasa R, or I don't know what are those things lah. So if you girls know, do you guys any girls here know about Bahasa F?
It used to be a trend back then.
Yeah. So that one is a part of encoding. Okay, one style of encoding. So means that you convert your original message and insert some foreign element that alter the message so that some other people cannot understand. Okay, like these days we have WeChat language. So WeChat language also almost similar as encoding, but more complex one. You need a very higher algorithm to do that. And honestly, there are lecturers who are researching for WeChat language. There are lecturers who are doing research on WeChat language to find out potential sexual predator or potential crime against children. Okay, they study the WeChat language so that they can do some algorithm to trace possibility of sex offender or pedophile with children. There exists some kind of research like that. I saw that once and I was really amazed on her WeChat vocabulary. Okay, she can translate almost all WeChat messages style. So those kind of things are what we call encoding and decoding. Encoding means you convert to WeChat language. Decoding is from WeChat language you convert to real language. This is encoding, decoding. So during World War II, okay, they don't have computers, so they create some sort of encoding machine and they are decoding machine. So the first person who invent this are the Germans. Okay, and then there is this is what they want to tell this whether this is a real computer or not. I don't know lah, because of course because the winner was the Allied British and UK. They say that the German one doesn't count as computer, and the British invent some kind like encoding and decoding device, okay, that can trace those encoded messages lah. So this one you can see in a movie. We have a movie starring Benedict Cumberbatch. I forgot nama dia. Movie that one. So he was a professor that was given some task to develop new computer to decode German message. So they use that so that they can understand the plan and strategy of the military. So this is what they did before, and then afterwards they use that for missile and mortar location trajectory tracing. Okay, means that if you want to put missile and mortar in a accurate place, they use computers to code where should they do it. Okay, and then up until the space age where they send astronaut to the moon, they send astronaut to the space. The Russian and the US, okay, they start to inventing more sophisticated computer with the help of the first computer company, which is the IBM. Okay, so those programs, okay, you notice that when you write an algorithm, you have a lot of shapes, and then the shapes are start with circle, oval, and end with oval, start and end. Okay, so during that time, all codes they work like that, start end, they start straight line towards the end. Okay, so during that time they haven't invented the looping or something like that lah. Okay, now we have a lot of looping lah. So those programs, okay, at the beginning they were written using binary. Okay, binary means 101010, and then they have a chart where you call it a hexadecimal chart. that helps them to analyze binary even more efficiently. Okay, so after there are a lot of codes during that time in 1940s, 50s, 60s. Okay, we have uh, 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 not very sophisticated computer. Okay, the computers are not very high tech like we have today. So the codes usually are not that long. So they can operate them in binary. And to simplify the binary, they create what they call assembly language. But these days, because our computers are more advanced in hardware, you can write longer codes, millions lines, everything. So in order to simplify those codes, okay, this is where we invented programming language. If you've seen in a meme inside internet, okay, like 9gag or whatever, right? So there are some old woman standing next to a very tall book document called the codes that she invented for NASA moon landing. Okay, so during that time, okay, that was the limit of the coding. Okay, because we are using a language we call assembly language. So assembly language is a simplified binary language. So when they look at, oh, those code is very long, they need another form of simplification where they invent a more simpler code like C. Okay, C is one of the most the first simple code that is being invented after during 1970s 1970s. Okay, so we have this machine language. Okay, machine language here is where we have 1010, which is the binary. And to simplify the binary for the reader to understand the codes, they create the assembly language. And to simplify the assembly language even further, they have this high level language. So what you are doing with C, Python, everything we are doing here at high level language. Okay, so machine language, okay, usually they are very primitive, okay, which is 101010. This is the binary. Okay, if you say that, oh, what is binary? 101010. Okay, 1 plus 1 equals 10. That is binary. Okay, so binary, why they invent the binary is that because our computers are mostly invented by construction of transistor. Okay, if you have heard about transistor, transistor is a form of switch, auto switch. Okay, switch. So what does switch do? It turns on and off. So when a switch turn on and switch turn off, they give a signal to another location. Okay, so like for example, if turn on, it become 1. If turn off, they become 0. Okay, so computers, they are created out of millions, even billions of these switches. Okay, so that's why your machine language is a combination of on and off. So combination on and off is what operating the pixel in your screen right now. Okay, so certain color is represented by certain binary. Okay, so these are operated by a lot of transistors to make what we have right now, like what we are doing in our lecture right now. Okay, so the assembly language, okay, is basically a simplified version of a binary program, okay, that you can write using a simple instruction. Okay, like this one, ADD F3 R1 R2 R3. So this R1 R2 R3 F3 here is what we call memory location. Memory is a group of transistors that can sustain information. Now this is what we call memory. So when you add certain memory location to another memory location, as this instruction represent, okay, they will go towards the assembler, and the assembler will convert them into a machine code and give it to the CPU of the computer for the CPU to conduct the process required to conduct those operations. Okay, so during this time, this is what we call assembler. And right now, we still have those assembly languages for certain application. But because of our high-tech computers right now, for you guys, okay, C is the minimum. Okay, even in the future, I think C might not be used in teaching and learning for Faculty of Science Technology later on. Maybe you guys will learn from Python because Python is a little bit more higher language comparing to C. What does it mean by higher language? Means that the coding part is more simplified. Okay, so next we have these high level languages. Okay, so high level language is what you do the coding right now. Okay, so like for example, you want to calculate a uh, uh, radius of a circle, okay, with a radius 5, area of a circle with radius 5. So you just do it 5 times 5 times pi. Okay, then you get the area. So this is what we are going to do so far. Okay, so you don't need to create the 101010. Okay, those 101010 is for those who are taking computer science, electronics course. Okay, you just worry about how to calculate. Okay, so when you want to do codes, okay, simplified codes, and why do you have to why do you have to learn programming? Okay, for like for example for Faculty of Science, why do I have to learn programming? They already program out there available. Okay, honestly, I mentioned to you, okay, some of the program can help you, but when you are doing some new things, complex new things, like some of you might later on become a lecturer or scientist later on, because most of the science students they tend to become researchers and scientists as well. So some of the programs, they do not pre-made program, they do not have the options that you need to conduct your research, because you are so advanced, you are new with a lot of things. So those software, they don't have, they are not up until your level yet, so you have to create the codes yourself. Okay, so this is a lot of a lot of things happening here in Faculty of Computer. Okay, Faculty of Computing here, where phys lecturer, okay, collaborate with computer science lecturer to create codes to help the phys lecturer in terms of biology problem or even in chemistry problem. So this is a lot. So if you can understand how things work, it will be easier for you to learn to implement those knowledge into codes and then help you do calculation later on. Okay, so we have a lot of language, okay, a lot of language for you to learn for coding. Okay, so all of them are used for certain purposes. Okay, like we have COBOL, which is, this is one is for statistics mostly. Fortran, okay, for calculation. This is for differential integral calculation. There are a lot of they use a lot of Fortran. And then we have basic, Pascal, Ada, C. Okay, C is what we are going to teach you within this semester. And then you have Visual Basic, Delphi, C++, C++, and advanced of C. And then you have Java. So Java is one of the most common language that is being used right now, even within the Faculty of Computing. Okay, so since it is more widely utilized, okay, worldwide. So the person who invent the C program is here, Dennis Ricci, already died. He died, I think, last 2 years, and nobody cares because nobody know him. Okay, he's the inventor of C. Without him, there are no iPhone, there are no MacBook, there are no laptops, no Windows. Okay, he was the one who invents C. So from C, they create the Unix OS. Unix OS is the base of Linux, where it is the base of Mac OS. Okay, Mac OS. So if you're using smartphone like iPhone or Mac, okay, this person is much more valuable in your community comparing to Steve Jobs. Basically this guy. Okay, so this one, he created the C for simplifying a lot of computer languages. Okay, and then he created a compiler to assist like the assembler assisting assembly language. Okay, so when you want to do the coding, okay, so you have to create, usually we have a word processor, okay, the one that you do the coding. Okay, like now we are doing code blocks is doing everything. Previously I can do programming with the Microsoft Word, save it as text file and then run it in a compiler, and if successful you create a binary file. Okay, binary file is a file out of exe, and then you have a linker, okay, that link with another file. Usually this is linked with a library. Okay, and then loader, and then you have the result here. You can input the data, this one runs the codes, and then you can produce results. So this is how the programming environment works. So and then in programming, there are 2 points that you need to know. Okay, the first one is what we call syntax, and the second one is what we call semantic. Okay, syntax is a formal rules on how instruction are written in programming language. Certain words, like mentioned before, certain word is being used as an instruction in programming. So you cannot use that word easily as a variable. Okay, and then they have semantic, which is a set of rules that determines the instructions meaning in a programming language. Okay, let's just look at this first. Okay, so when you write a code, okay, like I mentioned before, writing a code is like writing a movie. Okay, like you are a fan of Transformers, for example. So if you are writing a movie, so you are writing the script. So the script is the source code, and inside the source code, you have inside the script you have the person who is the main character. You have the person who is side character. Okay, so the main character here is the one that will influence the movie all the way. So that's why in coding, the main is the area that is being utilized to run all the codes. Okay, all the functions that you need to do for the code, for the program. And then you have functions. Function is like a side character that helps the main character achieve the purpose. Okay, so before you have the main character and then you have the side character, you need to have a background of the story. Where is it located? What time? Okay, is it 1940 or is it even 1600 or 2050, for example? The background information. Okay, so the background information is where what we call global declaration. Okay, this one represent what kind of function you are utilizing, what kind of variable you are utilizing, what kind of codes, means like some special codes that you are using that's referring to certain other things. Okay, so this is help you understand the language that is being used inside here. Okay, usually in global declaration when you do coding, this is most likely related to math. Okay, like for example sine, cosine, tangent. Okay, how do you, if you write sine, cosine, tangent here inside the main, he will not know about it. Okay, they count it as a variable. There's nothing defined for sine, cosine, tangent. So they use a header file that helps. Okay, uh, they use the header file like this /include. Okay, math, for example, that the header file will help determine, okay, sine and cosine is for this function. Okay, so if you put sine, okay, cosine or tangent, they will do this certain operation. So this is how we include the header file. So when the way you include the header file is like this, okay, /include stdio.h. This is where we used last week for us to write the printf functions, right? Okay, like for example, in this case, the conio one is not necessary. So stdio.h is enough for this one. Okay, here this header file is being used to determine printf here. Printf representing, okay, displaying hello world in the window. Okay, so this is what the printf means. And how the computer know printf do those kind of things? Okay, because he referred to the stdio.h here. Okay. And then other than header, we have identifiers. Okay, so we have two types of identifier: standard identifier and user-defined identifier. Okay, standard identifier, usually you cannot change or use it for other things. If not, your code will be error. And then user-defined identifier is the one that you can use to determine the variable. Okay, like for example, standard identifier printf, like I mentioned before, main, int, char, double. Okay, this kind of identifier is also used. Okay, why we use this one, I'll mention later. Okay, so this standard identifier, they have their function predefined within the codes, so you cannot use it for other things. And then you have user-defined identifier. So user-defined identifier is usually representing variable or constant, means x equal 10. Okay, so x Nabila equal 20, for example. X Razmin equal 10. X50, X53 equal 12. Like that. Those kind of things is what we use as user-defined identifier. So you will play around user-defined identifier a lot more with help of the standard identifier to conduct all those kind of functions that you want to do. Okay, so variable, this one during our previous class, I did mention about variable here. So variable doesn't need to be X only, X, Y, Z, okay? So it can be like this one, student name, student ID, student ad, telephone number, result. Okay, you can insert underscore in the middle if you want to. Okay, so this one, variables, what does it mean by variables? Variables is count as memory location. Okay, if you ask yourself, okay, my computer has how many memory? Yeah? How many memory? 10, 20 gigabyte, 30 gigabyte. Okay, so those byte representing location, memory location. So when you set up student name equal blah blah blah, okay, in the memory location, in a memory location inside your 32 gigabyte PC, for example, there is a note that inside that location is a value of this. If you say student name equal 1, okay, there is a location inside your memory which designated as student name, and the value 1 is inserted there. So this is what we call variable. So when we create variables, means that you are allocating memory location inside your PC to insert certain value. Okay, so in this case, okay, like for example, we have variable example. Okay, integer main, integer result. If result not equal 0, printf bad file handle. So here in this case, int result. Result is the variable or in the variable? What do you think? Anybody can answer me? Int mean
Result.
result is the variable here. Okay, this is the defined as variable. Okay, so if the variable result is not equal 0, this is not equal. Okay, now you know not equal. Okay, terkejut equal is equal not equal. Okay, not equal 0. Okay, printf equal bad file handle. So bad file handle will be displayed in your terminal. Okay, and then when you define variables, okay, there are a lot of variables you can define. And these variables is defined according to the memory size located inside your computer. Okay, so some memory location you can only put real numbers. You guys are science student, right? You guys must know about real numbers, right? You guys know real number? You guys know real number or not?
Yes.
What is the opposite of real number?
Imaginary.
What is the opposite of real number? Anybody know? Aina tahu opposite of real number?
Imaginary number.
Imaginary number, good. But imaginary number, we are not going to do it in programming. Imaginary number is higher level. So in this case, we have a real number, and sometimes we have a floating number, fraction number. Like for example, pi. Pi is what called as fraction of floating. 3.1415. They have point behind it. Okay, so when a variable have a points, okay, they need a larger memory location, and if it's a real number, they need a smaller memory location. Okay, so memory location limits how you allocate, how you define a certain information. Okay, so that is what when we want to determine a real number, we use int. Okay, integer. Okay, real number integer. So for floating number, we use float. Okay, float rate total means rate is in percent. For example, float 10% or something. Float is 0.1. Float rate is equal 0.1. Total is equal 0.0, for example. And then you have char. Okay, char is for character. Character means A, B, C, D, E, F, G. Okay, gender. Okay, M. So here, gender equal male. Okay, this is character M. And then you have character color 6. Okay, color 6. Okay, color 6. You guys aware with array or not? Matrix, array. You guys aware with matrix? Know about matrix? Matrix 2 times 1, matrix 3 times 3. Akmal tahu Akmal matrix? You know what matrix?
Tak, doktor.
Tak tahu matrix? Matrix yang like this. Okay, let me show you. Like this one.
Oh, ya.
Tahu.
Yang ni 1, 2, 3, 4 macam ni. You guys know that, right? Okay.
Tahu.
So color 6 represent the variable color is a matrix 1 out of 6. Okay, 1 out of 6. So maybe there are 6 row, 6 row with 1 column. So green here is in column 6. Okay, so this is matrix. Okay, this one I will mention. We have 1 week to discuss about that later on. Array. And then for variables, okay, like this one, we have include stdio H, integer main, integer a equal 1, return 0. Okay. So this is how you determine, you define the variable. Okay. And then next we have constants. Okay. Constant is like variable declaration, except the value cannot be changed. Okay. So like for example, if you put character, integer, floating point, string, sometimes you can change it. Like for example, you create a equals 0, a equal a plus 1, a now is equal 1. So those kind of variable can be changed. But however, you can use a different kind of declaration. Like for example, constant or define. You can define, like for example, define pi equal 3.1415. So that one means you define pi equal 3.1415. So you don't have to write 3.1415 when you want to times with pi. You just write pi. Okay, pi. Okay, so there's an example I mentioned later. Okay, so there are rules for identifiers. Okay, like variables or constant. Okay, So here we have, they must be in alphabetical character or underscore. Okay, alphabetic with numbers also can, and they or you can add with underscore. No other symbol other than underscore is allowed. Okay, you must consist only alphabetic character, digits, or underscore. There can be no embedded blanks. Okay, means you cannot put space within the variable. Okay, means that if you put space, means that they count it as two variables. Okay, they cannot count it as one. And you cannot duplicate a reserved word like main, printf. Okay, you cannot use that one. And for C language, they don't have punctuation characters such as at, dollar, or percent. But other language they have. So you need to be careful with that. I think percent they are still use it. They want to get when you do division, you want to get baki, baki of the division, the leftovers of the division. Okay, you use percent. Okay, so this is an example of a valid name and invalid name. Okay, so invalid name here for number one and one number. So the number here you cannot start with number. The valid you cannot the name here cannot start with number. They have to start with alphabet. Number one is in the middle or the back is fine. Then you have student name here, student underscore name. Okay, here student without underscore name. So this one is wrong because you have a blank space. This count as two variable. Underscore temporary count okay, it's okay. And then add temporary is not okay because add is being used for other things. Okay. Integer is count as a variable. Okay. Int cannot count as variable because this is used as to define the variable. Okay. So other keywords reserved for later on when you do coding is for. If. For is for looping. If is for condition. You have constant, continue, return, do, break, else, car, integer, switch, while, void. Okay. So all of these you cannot use them for your own purpose. They have their own purpose in the codes. Okay, and for data types, okay, we have integer, which is a real number. Float is for floating number. And then you have character, okay, which is for alphabet, Abu, Ali. Double, which is for a more defined floating number comparing to float. Usually double, we use it to define 0.0000, more lower than the first real number in front is 0. Okay, 0.1111, 0.00001. Okay, floating point, we can have more than 0 at the front, like 1, 3. But double, usually we use it for to define lower than 0. Not lower than 0 means that the real number point is less than 1. Okay. Okay, so the why do we do that? Because we want to allocate the memory location efficiently. Okay, like for example, characters, they can define, okay, based on range -128 to 127. This is basically reserved for your ASCII code, means that all the symbols and of alphabet or numbers inside your codes. Okay, they don't use it as for calculation. This is for characters. So you have 256 option of symbol here. And then you have integer. Integer is for you to determine real numbers. Okay, for 16-bit PC, 16-bit PC is quite old. Now your Windows should be either 32-bit or 64-bit. Okay, and then during 16-bit is from -32768 to 32767. Okay, so what if you put bigger than that? Okay, well, if you put bigger than that, the memory will not record the correct number. Okay, so this is the limitation of computer. You can only insert according to the assigned memory location. So float is from -3.4 e power of 38. 3.4 times 10 power of 38 to 3.4 power of 10 times 38. The times, I'm sorry, 3.4 times 10 power of 38 to 3.4 times 10 power of 38 here. So and then you have double. Double is for much more longer. Okay, it's for -1.7, not 1 point. There's only 1 point here. -1.7 times 10 power of 308 to 1.7 times 10 power of 308. Okay, if your numbers are within this range, you can use double. If your numbers within this range, you can use float. If your number is within this range, you can use integer or symbolize with character. Okay, and then when you want to compile, okay, errors in the syntax will be the most important thing you need to understand. So I've shown you before with code blocks that when you have errors, your code will not compile and the program will not be executed to create the binary file. So what kind of error here? In this case, you see that sin xy equal. So this means there are something wrong here. Usually the codes will be almost similar to your mathematical equation. Okay, so here is not a correct mathematical equation. This one is correct one. So there will be an error here. Okay, and sometimes you need to be aware about upper and lower case. Okay, if you are mistakenly write an uppercase in your variable, okay, originally should be lowercase, but you write an uppercase, it will count as another variable. It will not count as the one that you created earlier. Okay, will be count as another variable. Okay, suddenly like, okay, your name is Aina, A-I-N-A, small letter, Aina, and suddenly you write A large letter, I-N-A, and suddenly computer doesn't know you, something like that. Okay, who is the large A Aina? I only know about small A Aina, something like that. Okay. Okay, and for C language, semicolon is the lifeline of your code. Every time you write a line, okay, if it's not ended with bracket, it must end with semicolon. Okay, it's either two. When you write your codes in C++, it can either end with bracket, whether open or close bracket, or semicolon for each line. For each line. So when you write your codes, it's easy for you if you write comments next to the code. Okay, so the way you want to write comments is like this: /star, any comment you want to write, and then close with //. Okay, so this one I'll mention to you later on. Okay, in this case, it's example. Okay, good. Include stdio.h. So include stdio.h represent header file, means the reference of certain instruction. And then you have integer main. Before this, I use void main. Okay, integer main is the basic. Void is much higher. You can use integer main. Integer main bracket. You see, end with bracket and start again with bracket. And here you see you have /* variable declaration //. So this one is just a comment. Your notes lah, your notes inside the code. This one is for variable declaration. Integer A, B, C, F. You see that we have three real numbers A, B, C, and you have one floating numbers which is F. So, and then you have another code here. Another quote means that this is a comment. Actual initialization. A is equal 10 means that value of A is 10, value of B is 20, and C is equal A plus B. So C, result of this C, is equal 30. And print value, print F, value of C equals %D. So %D here will be replaced with the answer of C. If C answer is 30, when you write this code, okay, 30 will replace the %D here. So value of C equal 30 will appear inside your terminal. And /n is to open a new line inside your terminal. Means it will like you press enter lah. If you put /n, press enter, and then you go to new line. And F here is 70 divided by 3. You can see value of F, okay, %F is here, F, okay. D is for integer, F is for floating number. Okay, this one, once you practice them, you will remember it easily. And then you have return 0. Return 0 means that main is not representing any value at all. Okay, return no nothing. Okay. So from this code, you just want to present the value of C and the value of F from the variable A, B. Okay, so the terminal should appear looks like this. Value of C, 30, value of F equals 23.333334. Okay. So far so good. Do you have any question?
Doktor,
Yes.
yang stdio.hash tu apa sebenarnya?
Dia header file. Dia macam ni.
Header file.
Okay. It's like a reference book. Okay. So when you want to use printf, kalau tak ada ni, okay, let me just demonstrate here lah. You can see my code blocks here.
Yeah, code block.
Okay.
Yes,
So
doktor.
let's create new one. So save as itu chapter 2. Okay. So let's just start with integer main and then Okay, you can see I write my codes here. Okay, like this. I can build it or not, do you think? So who wants to something like that lah? Can I compile it or not? Is there will be any error or not?
Yes. Yes.
There will be error. You sure there will be error?
Sebab tak ada semi.
Okay, can I compile it? No error, see? So this means that all of this is the main inside the code. So C code will always start with this. Okay? So when you want to do other things, like for example, I put in printf hi. So let's build it. What does it mention here? We have error, one warning. Okay, 0 error, 1 warning. Okay, incompatible explicit declaration of built-in function printf. So right now the problem is, okay, the code doesn't know what hi printf is. Actually, code blocks know. Code blocks will autocorrect it lah. Okay, including the library, everything. But originally, the code blocks, the coding, the compiler doesn't know what is this printf means. Okay, you can see here. Okay, in this area here, okay, it doesn't know about the printf. So what if I include a reference book for you to know what is the printf? Okay, so if I build this, no error, you see? So this is what does it mean. Printf is originally not known inside code blocks, but because you have this reference book, stdio.h is connected to what we call a library. So this library is a list of instruction in case you put in printf what the computer should do. Okay, it's a simplified code lah, basically a function that is being simplified by other person. So you are using other person code lah for printf, basically. Okay, so this is why we need stdio.h. Okay, so let's just play around here. Like for example, I have integer m. Okay, integer m. Okay, so what does it mean by integer m? Again, I want to ask, what does it mean by integer m? Okay, in case you guys forgot, I'm allocating a memory location inside your computer for a variable m. Okay, this one and this one is different. Why? Because this is what representing where the code start. Okay, and here is the code. Okay, the program. So when I put m is equal 0. Oh, sorry. Equal 0. And then remember that I mentioned you, every line you end must with semicolon. Okay, here what does it mean? Okay, m in the memory location m, you put in the value 0. Okay, and what if we want to put the result, want to display m? Okay, we put %d here and then m. Okay, let's try to compile. So when we compile here, what happened? No error. So let's run. You see here, when I run, it go hi, m is equal 0. Can you see this one? Can you see this one? Can you guys see? Can. Okay. So what if I change m is equal 0 and then I add a new one, m is equal m plus 1. Okay. Now what does it mean? M is equal to 0 at the first time. So 0 is being inserted here, 0 plus 1, and this is the new m. Okay, m here is equal this m plus 1. So what happened when we compile? When you compile, you get m is equal 1. You see? It's quite fun actually. Okay, what if you do it even further? M is equal m plus 1 again. What do you think is happened? Okay, 0 plus 1 become 1, and then here 1 plus 1 become 2. So what happened when you run the codes again? Okay, you got m is equal to. See? So this is where inside your computer there is a place in your gigabyte PC whatsoever, right? You have what gigabyte, 100 gigabyte PC. There is a 1 byte there is being allocated for m. At the beginning, you allocate inside the m a value of 0. And then you add 1 to that 0, it become 1. And then you add another 1 to that 1, okay, it become 2. So this is how programming works. Okay. So you can add other things, like for example, I don't like numbers. I like ABC. Okay, so I want to use car. Okay. I remove this one first. So when you want to remove something from your codes, you can do it like this: slash star and star slash. See, it's being removed from your codes. Okay, so that's why they use it as command. So here, when you see it, okay, so when you see it, when you run it, what happened? 0 error. Okay, so what do you think happened here? Okay, where is the run? Okay, hi, m is equal 0. Okay, normally. So okay, now I would like to do a little bit of magic. Okay, let's try this one first. M is equal m plus 1. Okay. So what happened when you compile? What is the result?
1.
1. 1. Actually, it's still 1. Okay. So if I change here from 0 to alphabet A, what will happen?
A1.
So this is what you see. M is equal to 98. Why? Why? So why is it is equal 98? So this is where you have a problem with data types. Okay, so this one is alphabet, this one is integer, and now what you're representing is integer. So let's change this one, remove this one first. Okay, and then this one we change to C. C represent character. So okay, when you run, you got here M is equal A. See, so you can use capital M, like for example, you mistakenly write here M and then you write here capital M, and then here you write capital M. What happened? Okay, so when you run here, you got error. M is undeclared. What does it mean? Means that I don't know this one. I know small m, the computer knows small m, but the computer doesn't know the large M. What is large M? Because you did not define as large M. And if you change this one into large M, you get no errors. So now I know what large M is. So just to keep you confused later on and keep viewing my video, I put another one called character M. Okay. So here let's put M, and then here let's put large M, C. Okay, and then let's put M equal %D. Just to keep you confused. Just to make you confused so that you will look at my video even longer for my YouTube views. No, just joking. So M equal M and M is equal 1. So what happened here? Any idea what will happen here? Okay, we remove this one first. We will be more confused. What will happen here?
M equal M. M equal 1.
Large M is equal M is equal 1. Okay, let's run it. No errors, you see? No errors, huh? So when you run it, you get large M is equal M is equal 1. You see? Okay, so right now, I want to do it a little bit more different. I put M equal 1 on top, and I remove this bracket. what will happen? No idea. M is equal. Okay, what is large M? What is small m? M is equal. Large M is equal 1. Somebody answer large M is equal 1. Small m equal what? Small m is equal 1 juga. So, okay, let's take a look. Okay. So, you see, we have a problem here. M is equal what? Smiley face. You see? This is the problem occurred because of data types. Supposedly, here is a character, but you put in an integer. So, he is confused. He is confused. Okay, the computer is confused. Is it the data type or what? So here, for when you want to define, okay, like for example, this one is a number. You need to use it as a number. Okay, easy. Okay. Oh, sorry. This one. This one, okay. Characters, okay. Okay. If m is a start as number, so you put integer. So first. Okay, you see, we still have a problem. M is equal 1, but large M here is still equal smiley face because you still have this one to change. This one supposedly D because it's a number. So when you do it correctly, okay, you will get M is equal 1, M equal 1. Okay, supposedly if you use number, if large M is a number, use integer. Don't confuse yourself. Yes, kalau smiley face tu kira salah kod lah. Means it doesn't show what you intend it to appear. Okay. Sometimes smiley face tu is still good. Okay. Sometimes your computer shut down, so even worse lah. Okay. If you use it for numbers, make sure that you represent it for numbers. If you use it for characters, like for example, you want this to be character. The variable is character. Down here is character. Okay. And you make sure that you have this one as a character. When you want it as a character, you have to put in like this. And the printf also need to be C character. So when you run it, no error. And when you produce the result, you see this one is a character. Okay, it come out perfectly as a character. So what happened when you do it a character? Okay, like for example, okay, m equal m plus m. So this one, make it m times 2 lah, now times 2. Okay, so what will happen here? Let's take a look. Okay, here you see m equal m times 2 become b. Why the hell is b? Mean this is your coding is wrong because this one is a character. Okay, even though it's a number, but the data type is character, so it cannot be added or doing operation on it easily to produce the same result as mathematics. Okay, if you want to do numbers, you make sure that you do it numbers. Like for example, here integer. Okay, integer. Okay, times we use star. Okay, integer. So when you do star, you do run it. So what happened here? M equal large M equal 2, M is equal 1. So this is the correct one. Okay. So for you to not make mistakes, make sure when you do a calculation, you need to include a proper calculation data type. So usually we use integer or float for calculation. So in terms of float, like for example, we have float M. Float. So when you use float, you need to make sure you use %f. So m is equal 1.1234. Okay. So what do you think the result is? Because we use okay, integer. What do you think the result is? 1.2 lah now. So the calculation is easier. 1.2. The result should be 2.4, right? for M, large M. So what happened when we do this? You can see that large M is only at 2. Okay, M equal 2. So what happened when M equal 2? Why is not 2.4? Here is because you are using integer. Integer representing real number. 1, 2, 3, 4, 5. It cannot be a fraction number, a floating number. So here, to correct it, you need to change it to float as well. So here, result also in float. So when you do the compiling, okay, the result will appear as what you intended. M equal 2.4, large M equal 2.4, small m equal 1.2. Okay, so are there any other question? Any other question? Okay. For this week, okay, because it's holiday, I will activate the lab file today, today. So you can submit them before the next class, okay, like last week. Last week there are no schema because we are not doing the coding yet. Okay, this week there will be a schema lah. Maybe the schema is one of the good answers from your friend lah. Okay, so I will include them inside the column later on. Okay, so far do you have any question? So you can open your own code blocks and try this for your own discovery. Okay. Okay, how are you doing this? Why you become like this? Okay, question yourself. Okay, so trust me, when you are a programmer, error is less of the mistake. The mistake will be here. You define the float different, you define the data types wrong. Okay, so those kind of things can affect your coding lah. Even though there are no errors, the result might not be correct. Okay, so this is what you need to list off. Okay. Okay. Do you have any other question? No? Okay, please ask if you have any other question.
Jadinya doktor, before we start anything in code block, kita memang kena guna stdio.h.
Kalau you guna
Ke
printf,
boleh?
you kena guna stdio.h. And sometimes kan, if you want to use like for example include, okay, like for example math.h. Okay, so here I think I forgot already. M equal, for example, M equals 4. Large M equals squrt M. Okay, so you see that here large M is equal to M equal 4. Okay, so math.h help me with defining square root here. If I did not include this one, what happened? Okay, you see here, I don't this one, there is an error. Square root, not error, warning. Actually, code blocks helps a lot. Okay, if you use a traditional compiler, everything, they will not work. Code blocks help fill in the gaps. Okay, means that you forgot a header, they will include it automatically for you. Okay, so here square root doesn't know what is square root. So square root is inside, the instruction is inside math.h. Okay, so I think for your exam or anything, I want to include math.h lah, for easier for you guys to understand the coding and everything lah. You guys like to do math a lot, right? So okay, so here is an example lah. Okay, once you run it, you can build it. Okay, you can calculate them perfectly. So same thing with printf. Okay, if you pull out this one, okay, there will be a warning about printf because doesn't know what printf is. So this one, okay, we include stdio.h. Okay, so that's why you have the result here. Okay, any other question? Any other question? No question?
No, doctor.
Okay. So in case we don't have any other question, I think I want to stop the class today. So before we stop the class, okay, I will take the attendance. Okay, oh, we have one question here. Kalau kita tulis semua dalam satu row, we do everything in one row. Means like this. Means like this. Macam ni. You mean like this, right? Okay, betul tak? Yes. So what happen if we write everything in one row? So no error. Still working fine. The purpose it may not be any error, but the purpose of why we put a second row, third row is to help us look at the code much more easier lah. So best practice is that you use enter lah so that you can scroll here. It's harder to scroll left and right than up and bottom, right? So it's better for you to make it up and bottom so that you can know where is the problem is. So secondly, okay, when you the code, like for example, when you run a code, okay, they can tell you where you did wrong. Okay, like for example, if I miss one semicolon here, okay, I miss one semicolon here, they can tell you line 9 means here you create something wrong, means before this one. So here you need to insert this one. If you do it one row, okay, the long codes in the row will be, the whole of them is counted as error. So it's hard for you to find out where is your mistake. So it's easier for you to find your mistake in case you do it like this. Okay, so here in line 9 you can see that there is a error. You expect a semicolon before printf. So here basically. Okay, do you have any other question? No?